Hello and welcome back. This tutorial will also be on inheritance, and what we're going to do is take a couple more steps ahead and make use of the concept a little bit. We're going to talk about a person, and the person is also going to be an employee, and we can also have a dependent who is not an employee but is also derived from person. So what we're going to do is take one base class and we're going to extend and create two derived classes that are of different nature, different kinds, and see how that works. And I've actually kind of separated everything out to make it more proper, put it into different files. Again, you can download these files from bhacker.com in the Object-Oriented Design in Java section. What we're looking at in this example is dependent, employee, payroll, which is the driver program, and then the base class person. So I'll start out with that one first and explain that one. And then this other one here, read console, when I talk about payroll, I'll briefly mention that one. This is all included in this file, the zip file that you can download from bhacker.com, which will also give you the inheritance 1 and the inheritance 2 files and everything we used in the last video. So I showed you how to do system out to print something to the console. Read console is going to basically be the opposite. It's going to show you how to do the input. So let's look at inheritance first, though. So I double-clicked on person, and now I have properly demonstrating how to set the files. We have person.java, the name of the file. Inside we have public abstract class person. And so abstract, what in the world does abstract mean? Well, when we know that we are going to inherit and we don't want to reinvent the wheel, but we want to set like a template of what it is we want the class to contain, we can include the methods, we can include the class, we can do everything and just put bare bones in it. And abstract tells us that if we have an if we have an abstract method inside of the class, we have to declare the entire class as being abstract. And if we want an abstract method, we just basically give it the method name, and at that point we don't have to worry about actually creating the functionality. We can just leave it blank and just put the method name in there. So abstract, I'm going to start using just so you can kind of get a feel for, feel for what it is and how we're going to use it. Okay, so public abstract class person. We have private, which means it's not protected, it's private, which means it can only be, these two data members can only be accessed from person, and that's first name and last name. And they're private, so inside of person, we're going to set them. So we're going to set the name, we can get the name by using methods. Okay, so public person, that's our default constructor, isn't really doing anything. It's just basically, we have it. So we have public person, string name, string last name, first name, last name, set first name, set last name. So down here we have two methods that are going to say set first name, set last name. They're going to be called. We don't actually have them implemented. No, here it is. Set last name right here. Set last name. Here's set first name. Here's set first. We do have them implemented, which is good. We're saying this dot first name is equal to first name. So hopefully you remember that from the other video. We're talking about this object's first name dot first name. So we are using the methods to access and to modify, so the accessors and the modifiers, which is really good practice. So this is actually kind of, this is kind of the traditional de facto standard. This is the way you should do things. You should have private data members, and those data members should be accessed through accessors and modifier methods within the class, get name, set name, as examples that change the values of those two data members. So this is a good example. Okay, so hopefully we know that person has a first name and a last name at this point. That's really all they have, and the ability to set first name and last name. Okay, so we're going to leave person alone and go on and say, well, what if we want an employee? And our employee, in here we have class, public class employee, and it extends person. And you know, actually, as another example, I didn't have to use the word abstract in person. Just on as a side note, I could have just created a public class. This is what I'm talking about here. But I want to talk about abstract a little bit more in another video. In fact, I'll dedicate the entire video on the abstract concept. It'll be a short video, but I just kind of put that in there to experiment with a few things and to show you a few different options. All right, so public class employee extends person. That tells us that we're deriving a class from person. We're calling it employee. We're going to have, let's see, private static integer. Next ID is equal to 1. And so we're incrementing, we're setting a next ID is equal to 1. And you might have noticed now we have the word static. And static, as explained in another video as well, this one actually is going to be using it. And what we're doing is when we create something and we call it static, then we've turned it from an instance to a class variable. So it's a class data member. What does that mean? We can access it outside of the instances, and all instances of that class will share the same value. So if we want to keep track of how many employees we have and give them all unique employee IDs, we can set the next ID, call it static, as we have in this example here, and increment it, essentially. And when we increment it, you know, each new employee that gets created, each new instance of the employee object that gets created gets a new next ID, gets incremented. So it kind of demonstrates how that works in terms of the static concept. And there's a PowerPoint presentation that I've given probably it was in the inheritance, or may have been right after the inheritance PowerPoint presentation. If you look at that, it'll go into the concept of static as well. Okay, so we have some other variables here, nothing really particular. We have an array. This is the first time we probably have seen an array. And in our array, we're actually using dependents, which is another class that we're going to show you in a few minutes. That's going to be extended from person as well. And this is basically giving us the notation. We're creating an array of 5, which is going to be 0, 1, 2, 3, 4, because array indexes start out with 0. So we can hold up to 5 dependents, and we're going to keep it inside of. So we've basically created an instance of an object inside of an object. So the employee object contains an instance of the dependent object, which is, you know, kind of showing you how you can nest objects inside of objects as well. So yeah, we have classes that can have data members, member functions, and then instances of other classes, of other objects in there. Okay. So we have employee, and that's the default constructor. It's not doing anything. We don't really care. We just put it in there. And then we have public employee, first name and last name. And we're going super, if you remember that from the previous video. It's going to call the set, the first name and the last name constructor. So super says call the base class's constructor. And we don't actually have to now, at this point, we don't even have to do anything. We can just rely upon the functionality that already existed in the constructor that we're calling super, and we're sending it first name and last name. So we're going to set that information. And then here's another constructor where it's going to take the department number. So we can say, you know, super, first name, last name, same as before. Same concept as before, because we don't want to reinvent the wheel. We want to go backwards and use the base class functionality. But here we have another method. We're going to have to create a method called setDepartment and send it to department. So we have 2 calls in here. One to go back to the constructor, the other one to run setDepartment. And setDepartment is going to be down here, setDepartment here. We're just going to say this dot department is equal to department. So as an example, what we're doing is taking the person functionality, using it, not reinventing it. We're supering back to it so that we can use it, essentially. And then we have another constructor here that's going to set the pay rate as an example. Here's another one. These are all the same, really. This first name, last name, department. This one is setting the pay rate department. So we basically have examples of setting all a bunch of different assorted pieces of information. And so we have modifiers and accessors like before, get ID, get department, set ID, set department, get pay rate, add dependents. Where we're going to say and inside of our array, we're going to say, add dependent. So if the number of dependents is less than dependent length, which means we have room in there, then dependent, take the dependent, increment it from 0 to 1 to 2 to 3 is equal to new dependent first name, and this is first name, last name, calling this in terms of this employee's, this object's dependence. So we'll get into that actually in a few more minutes as well. But new dependent is basically going to create a new object and put it in the array. So we have an array of objects. We're going to have a string here. We're going to have list dependents. We're going to go through and it just prints it to the screen essentially. So I get pay information. So we've made some modifications to the class employee so that we can have a fully functioning person who's also an employee. Now let's take a look at dependents. So you're using dependents inside of employee. So what is dependent? Well, dependent is actually kind of a trivial, kind of a small little class here. And in the public class, dependent extends person. So we are essentially using the same base class. Now we have two derived classes from it because we have dependent and we also have employee. And we're using a class inside of a class because employees have dependents, and we're using that inside of the employee class. So now we have another data member, which is going to be employee dependent of, because the dependent needs to keep track of what employee they belong to. So when we create a dependent, we're going to have employee dependent of, and a first name and a last name. So we can super back the first name and last name to person and set that, and then this dependent of, which is the data member that belongs to this particular extended class, is equal to dependent of. And dependent of is the object that we're sending it. So we're going to say Joe, employee Joe has first dependent Mary, second dependent June, whatever happens to be the list, up to 5 dependents essentially, because we've created an array of 5. And then we have a default, another method here, employee get dependent of. So we can find out who's dependent of this. And we're calling it actually employee because we want to know which dependent belongs to which employee. It's going to return the dependent of the employee. So the employee's name is going to come back in terms of who we're looking at. Okay, so hopefully that wasn't too confusing for you. Let's take a look at the driver program. Let's call it, it's actually called payroll. As I mentioned before, you can call it main, driver, or you can give it a name. And usually the name is more meaningful as to what the particular example is going to do. So this is the payroll example, obviously, because it's working with an employee and dependent kind of thing. So let's see. Public class payroll, and we're importing Java I/O. I talked about importing in one of the PowerPoint lectures. If you missed that, go back and take a look at that. And this is when I started thinking, maybe I should put together a read console example. Because what ends up happening is, what ends up with students is, you find out one way of doing it, and you use that same way over and over again until you've kind of like learned how to do it, and you don't have to like remember it anymore. If we want to get input from the console, there's actually a couple of different, depending upon the Java version, there's a couple of different ways of doing it. This is just one way. In a future tutorial, I'll show you more ways. But here we're using an input stream reader, and I'm calling it ISR. So we're creating an instance of the object input stream reader called ISR, and it's going to be a new input stream reader system in, which is going to basically take the system input, put it in, and this is creating buffered I/O essentially. And then we have buffered reader BR is equal to new buffer reader. Well, take the system I/O, take the system input. So buffer reader is a new input stream reader. It takes that object and puts it into a buffer, and then we can use BR buffer reader to kind of go through and pull out the information. So if we come down here, we see buffer reader dot read line, which is a method that we can call on the object of buffer reader type and read the information, essentially read the line, read a character, parse a character, and manipulate the text. So this is kind of, this is in fact, let me go back to this example out here. This is inside a read console. read console, the example that's included in here, is basically doing just that without all the class information. So it's taking, and the class is called read console, and it's just a simple example to show you this code here, so that you can kind of get a feel for the template of how to create this buffer reader. And it's actually kind of demonstrating the try and the catch as well. Exception handling, which I haven't really talked about yet, but it's kind of an important practice. So you could probably leave out the try and catch, and it's still going to work for you, hopefully. But it's just like exception handling in C or C++ or any other programming language. You're aiming to kind of minimize the problems that might happen. Like say if somebody doesn't enter something in, or can't get the reader correctly, can't get the input stream correctly. And then here is a little loop, while s is the string that we created, while s is equal to br, the buffer reader, dot read line, it doesn't, dot equals, and while we have a character, do something. If it doesn't, exit out. And all this is going to do is report the length. So you can compile this example here. If you could pause the video, type it in, and run this example, you'll just see it'll come back and print the length of whatever it is you typed in. So it's just kind of demonstrating a little bit, just showing you the how to read input from the console. So, okay, let's go back to payroll. This is the driver program for my inheritance example. And we're creating a string, first name, last name, creating a null. We're creating a department, payroll. It is basically just some dummy information so we can run the example. So employee space E is equal to null. What does that mean? Well, it's just nulling out an employee, essentially. Which is basically kind of showing you how you can kind of create a template object too. System.println, enter first name, get the first name, get the last name. This is why I was showing you the buffer reader, so we can input information in, and we'll see this run. And then all the input that's being put into this buffer reader is in the form of a string. So we have to parse the string into a float, into a double, into an integer, in order to use the information, which is why we've got here department equals integer.parseInt. And parseInt's a method that comes out of the object type integer. So when we do this, in fact, what we're doing is basically saying parseInt from integer, then as a parameter, take this read line and parse it, essentially. So department is going to turn it into a number instead of being text. These are just text, so we don't have to convert first name or last name. System.out, println, enter pay rate, and then we're also going to, probably could have parsed it into a float. We're going to parse an integer out of that. I don't know why, probably because I didn't want to confuse you. So if pay rate is, let's say, less than 0, 0, I guess we probably could have just put 0 in there. Print out, the pay must be larger than or equal to 0, while the pay is smaller than, ask for the pay. So E is going to be now equal to a new employee. So we didn't have to do this. I did this as an example to show you that we created a null object that wasn't anything. We could have just said employee space E is equal to a new employee. Instead, we can, because we created that variable, we initialized it, or we declared it already, now we're initializing it. And we're going to say E is going to be equal to a new employee, first name, last name, department, pay rate. Okay. And then after we've created the object, we're going to add the number of dependents. So system out println, how many dependents? Number of dependents is going to be, we're going to parse integer again here. We're going to read the input, and then we're going to loop through and then say, if we have 5 dependents, it's going to say dependent's first name, dependent's last name. So for D is equal to 0, D is less than the number of dependents, D++. Just like C and C++, actually. In fact, you'll find if you know anything, if you've programmed in C before, Java is really easy because it follows a lot of the same syntax. So the if, then, else, the for loops, the while, the do whiles, all of the same syntax. And this is an example of a loop. If you're not familiar with looping, get yourself a copy of that DDL and DDL text, because what I'm showing is the object-oriented part of it. Basic Java programming. This is probably not going to be sufficient enough to give you everything you ever needed to know about loops, but this is the classic for loop. It has 3 components. You're initializing a variable to some starting value. You're checking the variable to see if it's less than or greater than something. And then you're either incrementing or decrementing the value of the control variable. Okay, so let's say we had 2 dependents. Well, it's going to do that. It's going to say enter first name, enter last name of each one of the dependents. And then we're going to go e.add dependent first name and last name. And then it's going to print out to get pay information, get list of dependents. So it's kind of more complicated than the first example, but it's really just the same. And so let's compile it, actually, and take a look at it running. I'm going to make this a little bigger. And here's the interesting thing, too. I can just take and compile the driver program and not worry about anything else, because it's going to find, if I go like Java C space payroll .java. Oops. Yeah, see it. I can't type here. Java. Okay, there we go. One of these days I'm going to learn how to type. Okay, there we go. We're going to find, because if you see this list up here, we see a dependent employee. Actually, I don't know why we had that up here, but anyway. And we don't have any class files. I deleted all the class files. But now if I list everything out, we got a bunch of class files. So we have dependent.class, employee.class. Because it started with the driver program and worked its way through. So, well, payroll, it uses employee. Employee uses person. So it went back through cursively and kind of compiled everything it needed. So now if I type in Java space payroll, which is how I would run this program, it's going to say enter your first name. Oops. Let's see, Barbara. I guess I didn't have to put a line return there. Enter your last name. Let's say Hecker. Enter department. I'll put CS for computer science. Oops. There we go. Lack of error checking. It wanted a number. And I put in a string CS. So it said number. I got an exception. This is probably another good example showing you how to troubleshoot problems. Now, because I didn't put any, and it was bad programming practice actually, I didn't put any exception handling in there. What if it could have done a check on the object to see if it was a string, to see if the input was, or it could have just tried to parse it. So I could have done like parse integer out of that, which I didn't do because I was expecting, in the program I was assuming the person was going to enter in a department number and not a character. So let me try this again. Actually, get back to a certain point, and then we'll see it work. Because sometimes when you're troubleshooting, it's not going to say department 1 this time. Now it's going to say enter pay rate. I'm just going to put $20 in here. So sometimes when you're testing, you'll end up with an exception like that, and it won't have anything to do with Java. It won't be like you have bad code or something like that. It'll be that it couldn't parse the integer because you didn't give it an integer value. So how many dependents? I'm going to say 2 dependents. And so now it's going to say enter dependent's first name. So I guess it could have said enter dependent number 1's first name. I'm just going to put here B. And enter dependent's last name, HE. And dependent's first name, that's because I said 2, RR, let's go AA. Some interesting dependents. So I have employee 1, and we know that we kept track of the employee because that 1 actually came from that next integer that we looked at in person. Department 1, my name, paid, that's how much I make, $20 an hour, I guess. And then I have a list of my dependents, and my dependents list here is B, he, and RRA, whatever. The 2 kind of fake names I put in for my dependents. So you can kind of see how this program's not bad because it demonstrates a lot of interesting things that come up naturally in terms of what happens when I start compiling and running something. So anyway, I hope you've enjoyed the payroll example. And again, you can download the files from bhacker.com. The next video will be another example on a different concept. I will probably do a couple more inheritances so we can kind of see, example after example, sort of see how it runs. But anyway, I hope you enjoyed this video, and I will see you next time.